everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about modernizing data science and analytics in the cloud while minimizing business disruptions. Our sponsors today are Impetus and Databricks. For our presentations today, we'll hear first from Dave Stoddard with TDWI. After Dave speaks, we'll be joined by Satish Garla with Databricks and Sunil Gowrie with Impetus. Before I turn over the time to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. If at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, please click on the Help area located below the slide window, and you'll receive technical assistance. If you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. If you'd like a copy of today's presentation, locate the Resource Center there on the bottom right of your console. And finally, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share with a colleague. Again, we're going to be discussing modernizing data science and analytics in the cloud while minimizing business disruptions. And our first speaker today is David Stoddard. He's the Senior Director of Research for Business Intelligence at TDWI. As an analyst, writer, and researcher, Dave has provided thought leadership on key topics in BI, analytics, IT, and information management for over 2 decades. Previously, he headed up his own independent firm and served as Vice President and Research Director with Ventana Research. He was the founding chief editor of Intelligent Enterprise and served as editorial director there for 9 years. With TDWI Research, Dave focuses on providing research-based insight, and best practices for organizations implementing BI, analytics, performance management, and related technologies and methods. Please welcome Dave, and with that, I'll hand it over to you now.
Thanks, Andrew, and welcome to everyone today. We certainly are focused on a topic that I think is core to the TDWI community, so I know we have a great attendance today, and so I want to thank also Sunil and Satish for joining us today. We're going to have a great roundtable discussion, and certainly looking forward to your questions that you can pose to us as we get to the audience Q&A. So I'm going to just do kind of a 10-minute setup presentation for our discussions to follow. So offer some research perspectives from TDWI on modernizing data science and analytics in the cloud while minimizing business disruptions. Certainly a balancing act there. So cloud migration and modernization is definitely a top priority we see in our research. Hasn't slowed down. You know, I know the cloud has been with us for a while, but or if anything, it's accelerating. In our see in our latest research, 54% saying they're actively modernizing data platforms, data integration, and data management now, and 29% want to in the near future. And along with that, modernization is moving to the cloud, migrating to the cloud. As we can see here, migration, it ranks as the top modernization objective that organizations have. But often the focus is really on data. It's about data management. How do we get the data to the cloud? How do we move things like ETL or move to ELT in the cloud, things like that? And forgetting about really the analytics and really which is delivering so much business value, and they cannot really be left behind. And so there has to be more focus really on migrating code, analytics models, predictive models, statistics, algorithms, and related applications that you may have, tools and applications. What's going to happen with these as you move to the cloud? How are you going to move off of, say, legacy systems that are limited, and you want to move to the cloud and take advantage of the scalability, the more processing power, the ability to add more concurrent users, things like that, and take advantage of all these cloud-based data resources. And so along with data management, I think the best thing is really if they're kind of moving in sync, you're thinking about the data management as you're thinking about the analytics that are dependent on the data management, and also to maximize all the value of all the data, because often we see a motivation for organizations to move to the cloud is to set up cloud data lakes, for example, or data lakehouses to take advantage of unstructured and semi-structured streaming real-time data along with the structured data they may have with their data warehouse. And making more of that available for AI and machine learning and other analytics approaches. And I think it's interesting to look at modernization objectives and drivers and objectives and see how they really equate. So business drivers that we see in our research, organizations are moving to the cloud because they need more flexibility. That's often a top reason. They need flexibility to change. to sense and respond to market changes that are happening, to competitive changes, trying to move into new markets. There's a shift in customer patterns that they're detecting. Certainly we've seen that in the last 3 years or so with the pandemic, and then coming out of the pandemic, and different kinds of demand. It's affected supply chain. So supply chain problems are a reason for flexibility. And at the same time, legacy analytics are kind of hitting flexibility and scalability walls as you're trying to tap voluminous new data, complex workloads, run more models, test more models, a lot more activity there. And the delays, running it in batch or running it, off hours, things like that, that's not really working very well anymore when businesses are really so dependent on getting data insights. Customer centricity, we see that as a common motivation in organizations, as they want to put the customer in the center and understand customers, get a 360-degree view of customers, that this is something that's driving, data innovation, data-driven innovation in marketing and sales and service, and then real-time engagement online and through multiple channels. Analytics at the same time, you get these slow cycles, and so development and testing cycles must move faster to take advantage of often kind of ephemeral opportunities as you look at customers and through engagement and how to improve that very rapidly. So there's a lot of demand for actionable real-time insights. Digital transformation, so a lot of applications and business processes moving away from sort of paper-based legacy systems to digital systems, often in the cloud, increasingly in the cloud. And I think that's one of the big drivers that we see behind the modernization. And organizations want these to be more data-driven, analytics-driven, embedding analytics in these, having augmented applications so that you're using the smarts, the data insights that you have. And so organizations here, we see them wanting to move to the cloud to develop a new foundation for this kinds of analytics and AI and machine learning that's driving their digitally transformed applications and business processes. And then finally, reducing costs. Business drivers, it's always, how can we reduce IT costs? And certainly moving to the cloud is one of the ways that organizations are trying to deal with IT costs. But analytics need to be efficient on the other side, or else you're going to start to increase costs and really not have a good handle on what are the cost drivers in the cloud. So analytics come with challenges. And so I've spoken to a few of these already, but skill sets, you're moving from legacy skill sets to things like Python, R, open source. So you got to make sure that your personnel are prepared for that, that you're got the training set up to handle that. Increased data access. Do you have, as you're moving to the cloud, is access becoming more complicated, particularly if it's in a hybrid multi-cloud scenario? Are you enabling continuous access? Because as I mentioned before, these analytics, you need data insights really for daily decisions. And so need to have continuous access to train, test, and deploy the models. We see here 66% looking for a major, at least some improvement, if not a major upgrade in this area to increasing data access for analytics. Silos, often, there's data silos, but there's also analytics silos that inhibit sharing, curtail reuse. Governance becomes very difficult, governance of the data and the models, and not taking advantage of cloud innovation. So as I mentioned before, as you move to the cloud, it's important to look at what's new. What can we do that's new to take advantage of it? And then some other things that are important, as I mentioned, concurrent users. So you're going to have a lot of user growth, particularly as you digitize applications and try to have them be more data-driven. You're going to have a lot of citizen data scientists out there who are not just full-time data scientists, but people who have day jobs, who are managers of supply chains and managers in other departments that are trying to do more analytics, particularly predictive analytics. So you have self-service users. Costs, visibility, you have the visibility into the drivers. Are you really taking full advantage of cloud elasticity? And are you reducing the benefit? Are you getting the benefits, in other words? So along with managing the costs, are you getting the benefits, particularly reducing time to value? So at this point, let's see what our audience is thinking. And so I've got a poll question for our audience. And so what is your biggest challenge in modernizing data science and analytics in the cloud? And so we've got several alternatives here. And then at the bottom, if there's one we're not mentioning, you can type the answer in the Ask a Question box, and then it'll give us, we'll address it when we get to the Q&A, audience Q&A at the end. All right, so the items are overcoming change management skills and people challenges. So really often that's something that's a roadblock. Having visibility to successfully migrate assets to the cloud. So all your analytics models, statistics, visualization code, algorithms. So all those key elements. Realizing objectives for higher and more efficient model performance. So that may be a goal, is becoming a challenge as you move to the cloud. Automating steps successfully to reduce manual work. Are you using automation effectively, and is it achieving the goals that you had set out for, particularly for reducing manual work as you scale? Maximizing the value of all data, integrating disparate data platforms, so data warehouse and data lake. So in other words, getting it so you're accessing all the data, that your data platforms are properly supporting analytics to support the analytics workloads. And then finally, cost management, having visibility into cost drivers. All right, so let's see what our audience is thinking, and I may refresh this just once to make sure we've got everybody. So here's our early poll results. Let me just refresh it one more time. Yeah, it stays in the same. Okay, good. So we actually have 30%, and I wanted to write some of this down. So 30% saying change management is the issue, and actually down here we see 40%. So the biggest are really maximizing the value of all data. So interesting there. So those are the two top ones, and then 20% saying that they're having visibility into the assets and being able to migrate them properly. And yep, so those are the three really that are the top ones. Okay, great. Thank you very much. So let's look at cloud migration just for a moment, since it's kind of in the background of everything I'm talking about. And here we asked a question in our research: what description best fits your primary cloud data migration strategy? And I should say that we found in our research that organizations don't use just one. They may use different ones for different purposes. So let's take a look. And it says 18% say that lift and shift is an accurate description of what they're doing, with 39% saying somewhat accurate. And this is where you're copying assets with little or no changes. There may be some re-platform approaches where you're doing some changes, but trying pretty much to leave everything as is, and often trying to move as fast as you can. And we'll be talking about some of the pluses and minuses as we go on. A lot of organizations try to do phased migration. So rather than try to do one big lift and shift, they're trying to do in phases, incremental. They test and validate components, evaluate alignment with workloads, make sure everything's working. And so some variations on this, and we see here 22% say this is an accurate description, 46% somewhat accurate. The larger percentages, 29%, the largest in our research here, start small and grow. So this is a cloud-first strategy, and this is often, organizations don't have on-premises assets, and so they're cloud first, evaluating everything, including cost drivers, before scaling up, leaving on-premises and somewhat systems in place, but anything new goes to the cloud. So that's another variation. So try not to affect things that are sort of working on-premises, but this, of course, builds in that hybrid and often multi-cloud environment that can be complicated to manage. And we do see 13% saying it's accurate to say that they have no overall strategy, or 32% saying this is somewhat accurate, 29% saying this is not accurate. So good to see this is in the minority, people not having any strategy and instead using a kind of a piecemeal approach. That usually leads to problems down the road. All right, just to conclude my presentation, I would say, seize the opportunity. So it's a disruption. You got to balance things, as our juggler here on the high wire is trying to do. But you want to seize the opportunity. Yes, there will be disruptions. Ensure the migration strategy is taking advantage of cloud strengths. Visibility is critical. So having visibility into all those elements and make sure you're moving them properly, but also into how you migrate and have visibility into cost drivers, what could be changed, because it's a different environment. Cost drivers are different. And make sure you're taking advantage of the opportunities that you set out to take advantage of in the cloud for efficiency, automation, increasing reuse, increasing sharing. Change management, we did see 30% in our research there saying this is important. So be sure you're addressing the people, the skill, the process adjustments that you need to be taking. This is key to reducing disruptions and taking advantage of modernization. And then, again, you're going to have more users. So analytics democratization needs to be a center of attention. You're going to have a lot more users, not just a data science team, but really, as you expand, the citizen data scientists, the self-service users. So you want to future-proof to ensure that all that you can handle, the more users, the more applications, business processes, different types of applications that may have embedded analytics, taking advantage of AI and machine learning. All right, thank you very much. And with that, Andrew, I'm going to hand it back to you.
Thank you very much, Dave, for that great presentation there. Before I get to our next speaker, just a reminder to our audience that if you have a question, you can enter it at any time in the Ask a Question window. We will be answering audience questions in the final portion of our program. This does bring me to our next speaker. He is Satish Garla with Databricks. Satish has a distinguished background in data management, data science, and risk management. He has extensive experience in implementing enterprise risk solutions such as mortgage loss forecasting, model risk management, stress testing for CCAR, regulatory compliance, and healthcare risk adjustments. He has previously leveraged open source tools and data technology to implement automated data science and use cases for businesses across different industries. Currently, he works as a solutions architect at Databricks, helping enterprises leverage cloud and lakehouse adoption via open source technologies such as Apache Spark, Delta, and MLflow. Please welcome Satish, and I'll hand it over to you now.
Hey, thanks, Andrew. Hello, everyone. Thanks for joining us today. Before we get into more details around Roundtable, where we are going to deeper into some of the core topics, and good to see the poll. I think, the challenges that you mentioned definitely aligns well with the thought process we had in terms of sharing with you. So before I get into more details, I want to start from here in terms of looking at the data maturity curve. So if you look at where the competitive advantage has been in leveraging data when trying to meet business goals, most of the innovators are towards the right side of the picture, where they're trying to predict what's going to happen, how we should respond to customer requests, and make automatically how customers make best decisions, right? Whereas on the left side of the curve is basically looking at what happened. This is area where you're looking at the data and then helping address questions or coming up with reports. But in order to achieve both the spectrum or move towards the right side of the spectrum, right? So you're basically looking at leveraging multiple technologies. This is what we've seen. Organizations have achieved success in this, but then the way they do it is by having multiple technologies or frameworks like data warehouse for your BI, trying to address what happened, and the data lake mainly for your machine learning and AI related activities that helps you address what will happen, right? But these two technologies are incompatible in the sense in terms of the data. You need multiple copies of data stored in a different format, and also the security and governance framework across these two technologies is different. And on top of that, the core thing being the use cases, business use cases they support are again different, right? So this is what we at Databricks, we try to address this using what's called a lakehouse, right? Bring all your data, put all your data into a data lake, whether it's in any of your cloud that you're using, just put them in your data lake. And on top of that, give more reliability and performance using a technology called Delta Lake, without moving your data out of the data lake, and then that can contain any type of data, right, like structure and structured. Once you have that reliability and performance achieved, now you could really use the same data in the data lake for data warehousing needs. On top of that, you can use something called as Unity Catalog that assesses with more fine-grained controls of who is going to use what, and then helps you identify what your usage has been, adoption has been in the cloud, set up security. And on top of that, more importantly, this framework addresses organizations with different types of use cases, right? From data warehousing, data engineering, or working with real-time data, working with streaming data, right? And also data science and machine learning. So what have you achieved by doing this is essentially you kind of simplified your overall data architecture, right? So you're doing all different personas are now working off the same copy of data, single source of truth, and there's really no duplicated data. And then it's all built on open standards, which means it has direct impact on your cost, and you can easily tap into a lot of talent pool. There's a lot of innovation happening in the open source world, which we're going to talk about in the roundtable. And then it can work across the multi-cloud nature, whether your data is in one cloud and then there's a different team working on the other cloud, it does support. Now, especially for today's discussion, on the machine learning and data science side, when you're talking about cloud migration and adoption, the ecosystem has changed significantly in the cloud, especially if you look at the ecosystem on the Databricks, how Databricks supports machine learning data scientists, with machine learning, there's so many different aspects that are put in place with using technologies like Delta, which handles a lot of data-related governance, gives more efficiencies and makes the data teams productive as well when working with data scientists. And then using MLflow as a basis to track all your experiments, you then can have a clear visibility around what's happening. What are your models? You could really comply to a lot of governance requirements in-house. And then finally, from a modeling perspective, right from data preparation to model scoring, which can involve you're managing feature stores, using different open source algorithms for model training and tuning, and then putting this everything together and then creating jobs and automating this entire process or supporting this process with AutoML can be achieved in this in the platform itself. But more importantly, what we want to support is more collaboration between data scientists. Again, especially what we've seen is when you have a project team member, transitioning off, and then it has to be a smooth transition, and then this multi-language notebook supporting folks with different backgrounds can easily take on work that was already done partially or completed by someone, and then continue with it, right? So essentially what the key takeaway here is, when you're really looking at modernization, the world has different components. Then how do you fit it? What is the most useful thing for you is definitely something that you would want to consider. Now, in terms of modernization itself, in terms of value that is being added, Databricks, we try to bring value at 3 different levels, and especially on the data platform, on the infrastructure side. By adopting cloud, you're really looking at more benefits on the infrastructure because you're now doing things much faster. Things are more performant. You could really scale things as needed. So on the infrastructure side, you would be spending much less. Most of the times when you're looking at migrating your workloads, you're only looking at on the infrastructure side, okay, you're going to get some dollar benefits, right? But the significant value lies even more above that, in terms of productivity and also in terms of the business impacting use cases. Like productivity is essentially kind of looking at the architecture I mentioned. How do you minimize the data movement? How do you bring all different personas together and then work off the same copy of the data? A lot of times when we talk to the customer, the thought of, using data lake as a data warehouse is something people don't understand really. We do get response or a question saying, it's too good to be true? Because you don't want different copies of data. You want to leverage your data lakes as much as possible. And that's what we are doing with technologies like Delta Lake. On top of that, you should really look at, from a modernization perspective, what are the business impacting use cases? How many different types of the models that you're building for different types of use cases, like whether personalization, forecasting, or any kind of other types of predictions, depending on the business outcomes. That's where you would see significant value when you are really migrating, right? So we're going to dig a little deeper in the roundtable, and we'll cover some of these in talking to Sunil as well. Andrew?
Thank you so much, Satish. That was a great presentation. I will be introducing our final panelist for today. His name is Sunil Gowrie with Impetus. Sunil has an extensive experience in design, development, implementation, and support of cloud, big data, and business intelligence solutions. He specializes in big data governance and management and consumer data analytics with strong experience in cloud and on-prem ecosystems. He has also worked on development and implementation of digital data analytics environment on Hadoop cluster with a vast experience in insurance, healthcare, and finance domains. In the past, he has successfully led the design and development of various predictive analytics, data mart, enterprise data warehouse, data integration, and server migration projects. Currently at Impetus, he leads the migration of SAS analytics applications onto Azure Databricks Cloud for various Fortune 500 companies, enhancing and automating their cloud transformation journey. Please welcome Sunil, and I will invite Dave Stoddard to rejoin us as well so we can begin the roundtable.
Okay, good. Sunil, Satish, welcome, and let's get started. I know I've got a lot of questions set up here. Let me just get our slide set up, and we've got a lot of discussion topics, so we're going to see how many we can get to. But I thought the opening question really would be just, what can organizations gain? Because I think often we're trying to understand how to align business and what data scientists and data engineers and data managers are doing. What can organizations gain by migrating from proprietary analytics systems to services in the cloud based on open source technologies?
Sure. Yeah, so definitely a common question. Especially if you look at from the perspective of the our customers, our enterprises trying to make the shift, some of the values. We all know, we've seen from a cloud perspective, like they mentioned, there's definitely scalability advantages that you have when you go to the cloud, because now we have better control of how your infrastructure could be more agile in terms of, in terms of sizing your infrastructure as needed, right? You're not really stuck to a fixed setup that basically limits access to data and also access to engaging on new use cases, right? So definitely cloud really helps you to get started much faster, gives you flexibility in the workloads. So you're basically getting to your insights much faster, and also means you are taking on more work, right? More use cases, more data and AI projects. On the other side, if you really combine that with open source technologies, right? One thing for sure, it's going to have a significant impact on your total cost of ownership, which is what we've seen. And then the open source tools have come a long way, especially if you look at MLflow for machine learning, right? So it recently hit 10 million downloads per month, and that's phenomenal. And then you would see a lot of contribution happening to these technologies, and then the new capabilities are rapidly added. So overall, you'll see a significant gain in terms of being more innovative within the organization, and that's what we are seeing. By adopting open source technologies, you would really open up that innovative ecosystem in-house. Want to add anything from you?
Yeah, I think a couple of great points, Satish. I think just to build on top of it, I think like you mentioned, the cost of ownership kind of comes down significantly. The other thing is one of the things with modernizing your or moving to cloud also involves your data modernization, which also includes migrating all of your data from heterogeneous silo legacy applications or databases into a data lake. So what this actually enables is data democratization. With this, there are a lot of value that actually comes in, wherein previously people never had access to all this data, and now you have all of this data actually in a homogeneous system or in a place which is easily accessible. And that kind of opens a lot of possibilities that were actually previously unexplored, So that's one thing. And the other thing is, when you actually start migrating, you also change the culture and start adopting new development and IT management philosophies, with regards to DevOps. So what these things actually bring in is they actually add a lot more value when in terms of time to market, So you are able to actually change the culture, at the same time kind of bring down the effort that is actually needed for your traditional IT management operations, like development, testing, so on and so forth, So.
Yeah, definitely. This to touch on the collaboration also, right? Being on the cloud, able to internally as well, like the democratization that you talked about, whether it's models or your insights or data, now that can be made easily accessible. But then if you have a mechanism where you have to work with your partners or external entities, getting access to that data in a more in large size manner makes it much easier. Because I was talking to a friend who works for a large bank, and then they've seen transitioning from legacy world to the new cloud world. And he used to tell me, hey, before they used to build models, and then they used to get data from credit bureaus, which is more at an aggregated nature. So because they can only work with certain size of data, so now they were all looking at more data at a segment level or a region level in building their models. But now, because of the cloud, and then it's much cheaper to store the data, they are free to actually purchase full data sources, more granular transaction level data from credit card agencies or from the bureaus. Right now, they could actually build models at a more granular level. So now they're actually increasing the advanced analytics capacity of the teams as well. And there's technology in the cloud that you could scale and use, right? So that's a phenomenal shift in your practice as well. Yeah.
And I think just adding to that, like the same point, there is a lot of a scope for people to actually try something and fail and kind of explore another opportunity when you're in cloud. You kind of try to do something and you identify that there is a limitation when you're talking about your legacy applications, but the same thing does not hold true for cloud or when you're in a modern technology, like, right, wherein you actually try out something, it doesn't work, then you actually have this whole plethora of other tools and technologies or like utilities that are available that you can actually kind of quickly incorporate and test it out, so more and more you actually kind of, it becomes more about like wherein you can actually like try a lot of other options and kind of use something that works best rather than saying that, oh, my technology is so limited that I'm not able to do anything, my hands are tied, so you have all of these other tools and utilities that you can play around with and kind of actually make something that is a lot more like remarkable, rather than actually like your technology being your roadblock. The other point that I've actually like also noticed is a lot of time people when they're working with legacy application is like they have like this performance issues and other things that they talk about, wherein the infrastructure actually always like plays a part, when they're developing something or they're designing something, they always have to constantly keep in mind, is it going to work on production data? Is it going to work when the loads, month-end loads are more, so on and so forth. So they're always building for the worst and not the other way around. But when you go to cloud, you actually kind of actually like shifts a bit, wherein you can actually use features like auto scaling and so on and so forth that kind of helps you not to worry about these things, but focus more on actually the value that the product is going to bring rather than worrying about all these other aspects which actually like don't contribute much from a product value or a feature value perspective,
Agree.
Yeah, it sounds like the cycles can move faster, even the fail fast kind of ideas cycles faster. So maybe we can talk about our next couple of questions here. What is the right cloud migration strategy? Let's take this first. We saw that in our research, it's kind of across the map. Organizations using a lot of different strategies. Is lift and shift applicable when you're trying to migrate analytics and AI and machine learning to the cloud? What's your perspectives on that?
Yeah, I think if you're really looking at lift and shift as basically like rehosting something that's been that's in on-premise or legacy into the cloud, like in a virtual machine and running it, definitely you're not taking good advantage of the cloud. You're really not relying on a lot of cloud native stuff. You're still carrying some of the technical debt with you to a cloud. But then if we talk about the other alternatives, right, generally things like replatforming or refactoring, which is where you start getting into some of the benefits. And what we have seen is taking any kind of modernization should be looked at as an opportunity, because a lot of times, especially with legacy applications, things have been built over years, right? And a lot of times you don't even know how they're actually working. So there's like people not there, or there's no proper documentation. It even becomes harder to like refactor and replatform. That's why we've seen many cases where lift and shift was approached first, taking it to the cloud as early as possible. But in our, what we recommend at Databricks is, because the ecosystem has changed, especially with data science and machine learning, right? So there's like new frameworks in place. There's a new way of doing things. There's a bit of refactoring, re-engineering in some cases is the best way to approach this. But you need to be open. There are situations where lift and shift kind of a refactoring, right? Let's say you have something in a legacy programming language, and then it needs to be converted into like a PySpark or like an open source. Like you need to take advantage of Spark and Delta and all open source technologies. Then definitely you would be looking at replatforming, tweaking it lightly. Yeah, yes.
That's right. I think again, this is a very a difficult question to answer, because every organization feels that one or a combination of one or more approaches actually works best for them. So like we speak, lift and shift has its own advantages as well as its disadvantages. Like Satish was mentioning, right? Because you're actually trying to migrate something without actually making many changes to it. So one of the biggest pitfalls of lift and shift is, even though if it's considered to be way more faster, the problem that we actually notice is that some of the times when you employ lift and shift on applications, if we know that there are some underlying problems with the application, like pre-existing issues that we know that are plaguing this application, and we actually blindly go with lift and shift, what we are basically doing is we are taking the same problem all the way to the cloud, and it is going to manifest or show up some way or the other. And the other thing is like, and that's one of the key problems with lift and shift. The other one being the disruption that could happen to your business as usual, because you think that this is going to work exactly as it is, but for some reasons, if there is something where the assessment has not been done properly, it might be so native to the application or the technology that it was built on, it might not completely work, so it might end up being a disaster itself to begin with. The other problem could actually be with regards to performance, because you're not doing anything much to the code. So you would have actually like carried forward your same coding techniques that you use to build on this legacy platform onto cloud, So it could be like the way you've thought about how you do performance tuning on the legacy application, that just goes on to the cloud as well. So there is nothing much that you have done to it. And some of the things that you've done that are so native to this legacy application would really actually like blow up on the cloud. And you would see a performance wherein the performance is even more horrible than what it was on legacy application. And that time what really happens is there is the business is not able to see the true value that you have brought to the table by actually making them to move from a legacy application to cloud, So there are some pitfalls when it comes to lift and shift approaches. But again, we have known organizations that have actually like be able to assess their applications in depth and be able to like kind of use this to their best advantage. But again, adding to Satish's point, rather than going for reconfigure or refactoring or moving towards lift and shift, a safer option would be actually to develop something called as a hybrid, or the replatforming, wherein to start off with, you explore a safer bet, which is your replatforming, wherein you do minor tweaks and changes to your programs that will make it work on cloud without impacting your business greatly, but at the same time have something like a maturity model, wherein your eventual goal should be towards the refactoring to the cloud services, So I think replatforming would be something that actually works best. And if you see one of your surveys also, it talks about a lot of people actually go in small changes and increments, So if you're planning to actually like evolve your cloud strategy in smaller increments, then replatforming would actually be the way forward. And so that you gain the incremental advantage of tweaking it as you progress, and then finally move towards a complete reconfiguration or refactoring wherein you're taking the maximum advantage out of the cloud, Satish, anything to add?
I agree. Yeah, definitely. There's you need to make sure you're leveraging the cloud to full extent. And the reason why you moved. Yeah.
Well, I think that you guys kind of answered the question of steps. I don't know if you wanted anything to add there. I had a sort of additional question about automated tools. A lot of organizations are trying to look at how can we automate to make cloud migration easier and faster. But are there some issues that you need to be thinking about for data science and analytics modernization? How is that coming together in your impression?
So you want to take this because you're more doing this hands-on day to day. So.
Yeah. Again, I think there are two major challenges, right? Every time we actually try to migrate, So again, I'll go back to the survey or the poll question that talked about, the very first option that was there. What is the where is the maximum resistance from, And that actually happens to be the culture or the development or the software development cycle that the team follows. Or it could actually be with regards to skills, like the skill set that is associated with these people who are actually like taking part in the actual migration, So what really happens is like usually when everything actually starts falling apart when the assessment has actually gone wrong, So when you're trying to find out applications or assets that you want to migrate onto cloud, if you actually like not assessed your applications thoroughly, that is where that would be actually your first step where you could actually go wrong, be it with regards to your migration plan, or be with regards to your your migration timelines,
Yeah.
So where exactly automation helps in is like you have a lot of discovery tools that are available, that actually wherein you just feed your program or your application that you're trying to migrate, and it actually tells you like gives you in-depth insights about what your application is all about, how it interacts, or what it is what it's basically trying to do, and all these things. So once you have this assessment actually come from these discovery tools or automated assessment tools, you actually know exactly how complex is your application that you're trying to migrate. So
Yeah.
this is one of the places wherein it could actually help. Satish, you wanted to add something
Yeah,
to that?
definitely. Assessment, I think, is in the next slide, we got something. But in terms of the automation, right, what we've seen good success, there's definitely some areas where automation fits really well, and some areas where, you don't want to do automation because you want this more of re-engineering that you're doing. So you want to take advantage of it. Like cases like, if you have a lot of data preparation, it's like scheduled jobs, preparing data, then the logic is straightforward, hasn't changed much. There's so much that needs to be converted. You really don't have manpower, and you don't have documentation or like skill folks who maintain this, who developed this. In those cases, using automation, quickly converting into the cloud framework would make sense and gives you a bit significant lift. And then once you are there in the cloud, and probably tweaking it, optimizing it would be an ideal way. So we've seen a lot of success with like ETL side of things. And also once you build models, all your scoring code that you have today running on hundreds of models or thousands of models, you don't want to retrain those models, but you still have to support your clients with those models, in producing those scores or predictions. So that's where we've seen significantly migrated using automation, right? So you quickly get them on this business as usual. You're supporting our clients with those outcome or the results, right? And then once you're there, you could finally tweak or fine tune. But when it comes to model training, model development, it's significantly been the other side of the spectrum to manually train your models. Yeah.
Mm-hmm. Well, I think you hit some good points about having automation help with the assessments, and imagine also just with visibility. So visibility into the, what have you got? Existing programs, applications, workloads. It's often lacking, as I say here, and that can be a big source of delay. So what are your recommendations there in terms of addressing that issue?
Yeah, this is one area where automation can significantly help. Not converting the code, but then getting a good idea of what you're dealing with here. A lot of times when we go and speak with enterprises, they have no clue. Like things have been built over, like I said, over the years. So much of complexity. There's no ownership. People have left. There's no proper documentation. And then if you have to really plan out and prioritize, and then really see whether you can achieve your goals by certain X amount of time, right? You need to know the complexity of it. You need to know the size of it, right? And that's where assessment tools come in. There's like plenty of tools, especially profiling of workloads, categorization of complexity of the workloads. Definitely employ one of those so that you get a fair understanding of what can be done. Yeah.
Mm-hmm. Yes. I think automation also, like when you talk about case studies for automation, I think like maybe like I'm just giving, like when you think about like building a data lake, so that is where you would actually kind of try to use automation, wherein like pretty much it's ELT or ETL that is being built. So if you just want to migrate a lot of things out of this, you can actually kind of use automations wherein that the complexity is very, very less. And again, the points that Satish was mentioning, like a lot of things happening wherein people really, the ones who actually built it are no longer there, and there is very less documentation, and people really don't have the time or the resources to actually be able to like assess like what is happening inside this, So that is where kind of automation actually like helps. The other thing that we have actually noticed is like every time we have employed automation for conversion, like code conversion from legacy applications to like modern like cloud and Databricks, that we have noticed is that we have people are able to uncover a lot of discrepancies that were actually previously like plaguing the system, be it with regards to, because you actually get another opportunity to retest the same thing on cloud, so kind of actually brings in a lot those things that were actually hiding in the closet, like, like the issues that were plaguing kind of come in, and you have an opportunity to actually enhance your product, so wherein you have that one more round of opportunity to kind of improve upon, and without actually investing much, so
yeah, agree.
What about cost control? I have here a question about, and we do see in our research the organization want to control costs as a major motivation to modernize and migrate to the cloud. What are some strategies that work to manage and reduce costs?
Yeah, so definitely. I mean, the whole modernization itself, like I said, what we've seen, especially when moving to like open source and cloud, which gives better control of infrastructure. So the ROI is pretty like incredible in terms of like how much you could save overall from a TCO perspective. But then, if it's not managed properly after you slowly migrate to the cloud, for reasons of like change management, like I said, like one of the 30% of the folks, people like talked about skills and not knowing the system properly, right? That is also challenging, right? That can add up to cost. Basically, like whenever you write select start from in the cloud, you want to really understand what's actually going to happen behind the scenes, right? Because a lot of times the pricing, the cost is by number of like the size of the data you're extracting, how much you're viewing, what kind of tables you're joining. So we've seen cases where folks really didn't understand how a cross join is done on billions of records of tables, and then like blowing up things. So it's definitely enablement is essential, critical. There's always best practices in controlling costs. Like the path itself, while you're migrating, starting the migration journey itself, the whole activity needs to be properly planned, and then you need to have timelines. And the reason why it's important is you don't want to end up in a situation where you're actually paying for your on-premise system at the same time you're also incurring costs in the cloud, or you've got data spread across both the platforms, and then that's actually adding up to the cost. So you need to have a clear cut change management or a cutover plan in place that slowly brings over all the users and they're properly enabled, and then you continuously monitor how the usage is, right? That is very critical. And there are techniques in the cloud itself, like setting up some policies when somebody is spinning up some clusters, because like Dave, in your talk, you mentioned about self-serve being more self-service, right? So if you really don't have any guardrails, you would see somebody spinning up like a GPU instance or something for very small little task without even knowing, right? Accidents happen, or it's just from a convenience standpoint. So you really don't want to do that. So those are some of the pitfalls, but then, you need to have those guardrails in place in order to make sure you're really not like, hitting those cost challenges.
Yeah.
I think, just building on top of it, like it's all comes down to how you keep your house, like more like housekeeping, right? So when you are on cloud, you actually end up subscribing to a lot of services, you don't even know whether you need them or not. So it's better, like it's like saying that I want Netflix, I want Hulu, I want Amazon Prime, and so on and so forth. I want everything. But then after a period of time, like you have to go back to the subscription and see, do you really want them? Are you using them? How often are you using? The other thing is like the same thing, like, the lessons learned, like since just because we are moving to cloud doesn't mean that we have to actually let go of all the things that we have learned from these legacy applications, like talk about housekeeping of it, or like say data archival or data purging, So within the cloud itself, you can actually like say that like I would move my data from this access to like say a Glacier access after a period of time, wherein like the storage cost is lot more cheaper when compared to S3 storage and so on and so forth, right?
Yeah.
You can actually like think about how do you want to purge your data, how do you want to archive your data, or like in case like how do you want to push your data for something that you rarely use at all, so on and so forth. So basically the thing is like just be cautious that just because you're on cloud doesn't mean that you have to like forget about what you're doing, so always keep a tab on what is being used, why is it being used, and then always start small, like because most of the time, like some of the things is like you can have a cluster, like a standalone cluster for your development and testing, But when you actually go on to productionalizing, you can actually move to a job cluster, that you actually get spun up just when when your job is scheduled to run, things like that we have already done it, or we have used it for legacy application. Let's carry those good lessons,
Yeah.
lessons learned onto the cloud, and then that's how we would actually be able to save a lot.
Yeah. Well, I think maybe in the interest of time, I think all those are good things to put in place for future-proofing for modern strategies, unless you guys wanted to mention something in particular there.
Definitely, just the cost and the future-proofing, right? It depends on how simplified architecture you set up, or how you consolidate things into one place, leveraging single copies of data, leveraging a simpler connected system so that you don't have to really depend on multiple services, and then that builds up a lot of cost to maintain. So that's why with the lakehouse architecture I was talking about, it's really critical to consolidate. And that's what we've been trying to do at Databricks, is trying to simplify the architecture and make, again, realize your infrastructure costs, value in the infrastructure costs, right? And on the future-proofing side, going back to the data maturity curve I was talking about, I really think about, what kind of use cases you would be really hitting upon in the future as well, right? Like, a lot of times we ask, hey, what type of models are you building today? And they say, like, hey, I have, like, classification models, forecasting, or, time series forecasting models, right? But then don't just think about, hey, can I do time series forecasting in this service or in Databricks, or, like, it's just not that. Think about where your business wants to go. Will you be serving customers with, like, real-time decision making, right? Will there be a plan for your company to get there? Because you don't want to just focus on today, but then tomorrow again you're talking about, hey, I can't support so and so use case, so that's why I need, like, another upgrade or another migration, right? So think about all possible use cases that you would want to address with the data that you're building, and then plan for, future-proof the architecture that way, so that, next 10 years, you're really not looking at redoing this exercise. Right?
Yeah. Sunil, any thoughts there?
So is this question on future-proofing or the one that was previous to that? I'm sorry. Like, I think it kind of actually crossed over each other. So
yeah, just combine both because of the interest of time, right? So we just got 10 minutes.
I know, Sunil, you want to show some things, so maybe we'll just do that next. But if you had some thoughts about future-proofing, I think you hit the other question pretty well. So yeah.
Yeah, I think one of the other thing is that, like, I think future-proofing, like, the last point that I really want to add is, like, it is a journey, there is, like, change is constant. You kind of need to keep changing and always be on the lookout, like, what is happening new on the cloud, like you mentioned, David, like in the starting of the session, right? Like, keep checking what is new that is coming up. The other thing is also about, like, having a maturity model for your cloud itself, so wherein you have to, like, kind of move towards cloud agnostic models, so you can actually, like, be cloud native at a point, but future, like, I think to really be future ready, you literally have to build applications and use architectures that would help you, like, interportability from one cloud to another cloud, and that has to be, like, the application has to be really agnostic. And that is one of the biggest things that people have to invest, and that cannot happen overnight, because it's going to be very, very difficult considering the skill and the expertise that is needed. But having a good like a maturity model will help you that you actually develop applications that are cloud agnostic. So wherein you have the freedom of switching or playing around,
Yeah, that's where like, reliance on open source definitely comes in. Like, tomorrow you want to, like, move things very quickly, relying on open source technologies. You're not, like, logged into any proprietary stuff. You don't have to go through a lot of, like, migration on stuff, right? So using, like, Delta, MLflow, Spark, Python based applications would make things much easier for future.
Yeah. Well, Sunil, I think you wanted to show something, so maybe we should get to that so we have enough time for questions at the end. Andrew, how do you, maybe you can moderate that part?
Yeah, certainly. Sunil, I know that you're going to share your screen here for us, so you can go right ahead, and I will adjust the view for the audience as needed here. So give me 1 second.
Definitely, yeah.
All right, Sunil, go right ahead.
So, am I audible, everyone?
Yeah.
Yep.
Yeah,
And we
I
can
just
see the
want to
screen as
cover
well.
this demo on migration from legacy applications to modern technologies like cloud and Databricks and so on and so forth, right? So, and the reason why we wanted to do this demonstration was like how you can actually like kind of avoid certain pitfalls when it comes to migration, be it with terms of assessment of assessment of your inventory, and kind of be able to put up a very good migration strategy when it comes to migrating. And the other thing is like how automation can actually help you save a lot of costs that you incur when you are trying to convert something that is already there in legacy and you have to rewrite the whole program that actually works on cloud, so which is a lot of redevelopment, retesting, so on and so forth. So in order to avoid these two things and kind of save on these, one of the easiest thing would actually be to engage with migration partners or leverage migration tools or automated migrations tools. And so here I'm actually just going to demonstrate one example wherein, say you have an application that uses a legacy application and you want to move on to Databricks. So I'm just going to demonstrate that using our Leap Logic, which is a product that we kind of actually like use when we are working with organization, that are actually interested in migrating. So basically, the first part of this particular thing is all about assessments. So wherein you actually just feed in the program that you have, like say in this case, it's actually a SAS script. You feed the program into this and actually like try to get the assessment of that particular SAS script, and just a second. So what happens when you get so basically at that point when you feed this and try to get the assessment out of the tool, you basically the program or the product kind of takes in, analyzes the script and breaks it into SQL, SAS procedural, and other constructs that are there. So basically it kind of breaks down the program into various sections that are there. And you would be able to it tells you in terms of like how many sources that are there in this program, how many tables are used, how many stored procedures are there, how many macros are there, how many data steps are there, how complex is this program to begin with, So it just gives you a high level summary of your program, which can be easily downloaded. There is also an option to actually get a detailed report, which breaks this overall assessment into breaks it into breaks it further in terms talking in terms of the lines of code that you have, again the macros that the program uses, and then how complex this program is, So this basically performing this assessment step would help you understand like what really are we looking at from in terms of migration, So you get a better understanding and the complexity involved, and you can actually plan your migration strategy accordingly. And then once you have identified the processes or the program that you would want to migrate, we have something called as the transformation tool, which is an automated transformation tool that we use, wherein you feed in your SAS script. So it's very intuitive. All you have to do is like select a source type. Herein for this demo, we use SAS as the source, wherein you input your SAS script. Then you select your target, which is supposed to be like Databricks notebook. You select it as your target. And then your output type is actually a Python program that you want the output to be written in. And that's the transformation. And then you feed in your SAS file, which is the one that you want to transform. Once you save this, you go and execute this transformation step, save this as a pipeline, and then execute this as a transformation step. So now, once you execute this, what happens is the whole SAS program is converted into a Databricks equivalent program that is readily, like you can go ahead and execute it directly on the Databricks side. So just going to open that particular piece to see how it looks like. So here is the transformation step that is actually like says that the transformation step was successful. in case there are any transformation errors or failures that happen because of the code wherein we are not able to convert it, it would show up on the failure section saying that this section of the code was unparsed or was not converted properly, and it would actually give you the reason why it was not able to convert it. It could be as simple as like some syntactical errors, or it could be as complex as certain libraries not being available on some native functions and libraries that are not available on Databricks or on the open source platform, and then it actually tells you how many steps have been successfully transformed and how much time it actually took for us to actually like transform this particular program, and once the transformation is complete, you get a report that says everything, and then you also get a package wherein all of this transformed code is packaged into a package that can be easily downloaded and uploaded onto Databricks. So here you can see all the common functions that were actually there kind of actually gotten moved into a common library, and then all the functions that are common SAS Spark functions that we have used for this converting from SAS to Databricks has been pushed onto the SAS common functions, the Spark common functions library, and then your actual program that was there on SAS is translated into a PySpark Databricks equivalent program, and now using the download icon, you can just download this particular piece and then log on to your Databricks environment, import this file onto Databricks, and then you will be able to run this program on Databricks. So basically, what we have done here is we were able to assess, understand the complexity of the program, get a deeper insights of what actually are the building blocks of this program, or what are the various components that are there in this program. And that was covered as part of our assessment. And then the second one is the step wherein we transform the SAS program into its modern day equivalent, which is like Databricks in this case. And then we executed the transform step, and now we have, and that package that was actually like the output package is now imported onto Databricks, which actually looks like this on the Databricks once you import it. And this program is as good to be executed. And while you're executing, it would also tell you that if there are any dependencies with regards to sources, if there are any dependencies that are unresolved because of the parameterization, all of those things will actually be shown as part of the migration or the transformation itself, which can actually be resolved before you make them work or execute on the Databricks environment, So, and before I close this demo, and this is one of the features that we wanted to highlight, saying that how easy it becomes when we actually like employ automated migration, for our overall transformation. I think that's it from my side, Dave.
Okay, terrific. Thank you so much, Sunil, for that great presentation there. We will transition now into the audience Q&A. Unfortunately, we're a little strapped for time here, so I'm going to ask just one question, and I would like both Sunil and Satish to give their take on it before we close out the day here. So, Sunil, once you are able to get rid of the screen share, perfect. There we go. We can see everybody. So the question, again, will be for the both of you. How do we minimize business disruptions as we modernize data science and analytics in the cloud? Are there change management practices you would recommend?
Yeah, so I think, like I said before, you need to have you need to prioritize this whole migration, have a proper change management strategy in terms of timelines, the workload, and then the way you execute it is what we've seen been more successful is, do a phased approach, in order to see what you're getting into, in order to unblock or uncover any of the challenges you might run into. Pick those MVP use cases, pick use cases which are from different complexity range, try to get them done into and leverage automation as you see to get it to get it done faster. So that way, you know exactly how it looks like. And then based off that, develop a good success story, evangelize this with other teams, and then onboard more folks. Basically it's more of an enablement approach, plus creating champions along the way, and then slowly onboarding more users. That way you're much prepared. But on the technology side, definitely, yes, you need to take care of data being onboarded first and making sure all the data is in place and available in the cloud. Otherwise, there's like, bringing on the user, but there's no data. It doesn't really make any sense. Right? So that would be my take in just like a minute. Anything else to add, Sunil? You're mute.
I think that kind of covers everything. One is like, again, just to add, try to automate as much as possible the entire migration cycle, and also reuse as much as possible, so.
Okay,
Yeah,
fantastic.
Yeah, cool.
Sorry, Satish, I didn't mean to cut you off. If you had something to add, please go ahead.
No, nothing. Like you're saying, more of a templatized approach to migration would help. Yeah.
Right.
Terrific. Well, unfortunately, this does bring us to the end of our time today. I would like to thank our speakers. We did hear from David Stoddard with TDWI, Satish Garla with Databricks, and Sunil Gallery with Impetus. Also, thank you to Impetus and Databricks for sponsoring today's webinar. Please remember that we did record today's webinar, and we'll be emailing you a link to an archived version of the presentation, which you can share with colleagues. Also, don't forget, if you'd like a copy of today's presentation, you can locate the Resource Center to download the PDF. And finally, I'd like to remind you that TDWI offers a wealth of information, including the latest research, reports, and webinars about BI, data warehousing, and a host of related topics. So I encourage you to tap into that expertise at tdwi.org. Lastly, from all of us here, let me say thank you so much for attending. This does conclude today's event.
Thank you, everyone.